Aubrey, or should I call it Dr. de Grey? And a very pleasure to meet you, and welcome to the Superhuman and Owkin podcast. So, Aubrey, everyone talks about longevity every single day. And can you talk to our people that listen to the podcast? What is your angle on longevity, and what do you think is the biggest breakthrough that are going to be done in the next few years, and you already have done?
Well, my angle on longevity, what's that? Well, I mean, obviously I work on aging. I'm not in favor of it. I'm trying to fix it. I would prefer it if people did not get sick when they get old. I am trying to develop the technologies that will make that happen. You're quite right. Everyone talks about longevity these days, which is very different from how things were even 10 years ago, let alone 20 or 30 years ago when I got into the field. And that's very heartening.
What was the perception 10 years ago?
There was a complete fatalism about aging. Everyone basically said, well, it's just a fact of life. There's nothing we're ever going to be able to do about it with medicine. And people would just put it out of their minds and, get on with their miserably short lives and make the best of it. And now people are, I mean, of course, still, a lot of people still think that way. But a lot of people have come around to the view that we are within striking distance of bringing aging under medical control.
That's very interesting. It's difficult, I think, for people to understand when I speak about the angle is everybody has kind of one theory or one way to go. Some people just really work on gene therapy and saying gene therapy will be delivered at scale by the particles or viruses and be able to be the revolution. Other people, and this would be based on DNA. Some other people say epigenomic is the key. We have to reverse epigenomic. In terms of what molecule we focus on, when omics, the epigenomic, the genomics, what technology, is very difficult for people to understand what's the best. So help us, how can improve our knowledge about longevity, and what is the right way to think about things?
Well, I mean,
to learn more.
It should be difficult for people to get and handle this because aging is really complicated. The human body is a ridiculously complicated machine, and it damages itself just like any machine does in the course of its normal operation. And that damage eventually builds up to a point that causes a decline in function of the body, both mental function and physical function. So, in order to stop that from happening, we have to do a very complicated, comprehensive job of preventative maintenance, of eliminating this self-inflicted damage.
The senescent cells.
Yeah. Well, that's one example, but only one. The epigenetic noise that you just mentioned is another. So gene therapy is a way of implementing some of this preventative maintenance, some of this damage repair. Stem cell therapies, similarly, immune therapies, various pharmaceuticals. We can, at this point, I say, be really certain that there will not be any one or two things that we can do that will just do the trick on their own. We will have to do lots and lots of things all at the same time.
But nobody works on combining these different technologies. We'll work on one or the other. So it's a good idea. In practice, never happens.
Well, actually, you have hit the nail on the head. So in my organization, LEV Foundation, we do work on combining things. And the main reason we do it is precisely because you're right, other people do not work on that.
No.
It doesn't really align with most people's incentive structures because they want to, leverage their own intellectual property that they've got on some particular approach to this or that. It doesn't really fit academic incentive structures either, so it's very difficult for anyone to do this work. And I do it basically because occasionally I succeed in getting people to write me checks. In other words, my organization is funded entirely by philanthropy. Everyone in the expert community acknowledges and agrees that combining things is the way to go, but somebody's actually got to do it, and that's why we're doing it. Of course, we're only doing it in mice at the moment, but, as soon as things work really well in mice...
Enough model, but of course, translational gap, so towards the human.
There's a translational gap, but at the moment, the issue is simply showing a proof of concept. If you can get anything to work in mice, to work really well, like to give 2 or 3 times the amount of life extension that you can get with calorie restriction, then everyone in the expert community will agree that we're in a different universe, that the whole thing has become more feasible. And so then when we work on humans, absolutely it may end up being that the thing that works on humans is completely different or very different from the things that worked on mice, but at least something's going to work. Whereas if nothing works in mice, then you don't really have a starting point.
How do we have to think about the immune system? The immune system in cancer, I'm an oncologist by training, really is key. We think immunotherapy has been a real breakthrough. It doesn't solve it all, but the models are very difficult. People like using cell lines that don't capture the immune function or even organoids that doesn't capture either the immune function. And so we are very difficult finding a right time to find the right models to mimic human immunome or immune systems. And however, it feels extremely key to have the best immune systems to age well.
So I completely agree. The immune system pervades the whole of aging. Absolutely. Immune decline is an incredibly important thing. But actually, things are looking up at the moment. First of all, of course, with respect to immunotherapy against cancer, 10 years ago, 15 years ago, we were in this wasteland where there had been basically no progress ever. And then suddenly checkpoint inhibitors and CAR-T came along and, it's been transformational. There's plenty more to do, of course, but still. And then in terms of other aspects of immune decline, so, for example, there's now been very successful early-stage clinical trials on regrowing the thymus using growth hormone combined with metformin and DHEA. These are only small trials, early stage, but moving rapidly towards later stage because it just seems to work. Mm-hmm. You get quite a lot of thymic regrowth, quite a lot of new naive T cells, which of course, improves the effectiveness of the immune system against cancer, against infections, against everything.
But if you think about this idea, which is a great idea, like the thymus is very key for T cells, but why does it disappear in a normal human?
So no, that's not particularly mysterious. So it's just part of aging. The fact that the thymus atrophies so early in life is, intriguing, but it's not surprising because the way the thymus works is it creates this large, very diverse population of naive T cells early in life, and those T cells hang out. So that diversity, that polyclonality, does not start to decline significantly for decades after the thymus has more or less gone away. And therefore, there's no evolutionary incentive, so to speak, to make the thymus last any longer than it does. But of course, there is the medical incentive. We'd like the thymus to hang out more, and if we can't do that, let's regrow it. And we'll get a replenishment of our naive T cell repertoire, and that will be good.
Yeah.
So the point is, we want to maximize our resilience and maintain it at a useful level. And we have to ask, why did it go downhill in the first place? And of course, the answer is this accumulation of various types of damage that I was mentioning earlier, whether it's senescent cells, whether it's waste products in the lysosome, anything like. And these things are accumulating throughout life, even when we're young. It's just that the body is built to tolerate a certain amount of them, and therefore we only see functional decline later in life. But the idea is that if we remove these various types of damage, then we will restore the structure of the body back to what it was at a younger age, and that will restore the resilience and the intrinsic capacity and so on.
And two last questions. The first is like a young student, imagine one of the postdoc and interested in longevity. He might have to choose towards a lab that focuses on one type of cells. People focus on B cells, macrophage. If I was asking you which cell he would choose, you would probably say that there's not one that matters more than others. But it's the way to go for now. You have to choose a path when you do a postdoc, for example. Well, what do you recommend? Because at the end, you tell connection matters, but you have to start somewhere.
Right. So once one has accepted the fact that the way to treat aging will be a divide and conquer approach with many different things, then choosing what areas to research in comes down to really choosing what might be getting neglected. So in my work, for example, throughout the entire 23 years that I've been funding research, the areas that I have prioritized have been precisely the areas that other people have been deprioritizing, largely because they were too difficult and you couldn't get a paper out in Science or Nature or Cell every 10 minutes the way you need to in order to
Get funding.
Get your next grant application funded. That's right. So, so that's what I've always done. I think that general principle still remains true when one is looking for a place to do research. And I would say this is true at the PhD level as well, not just the postdoc level. Then one should look for areas where one can make the most impact, which basically means areas that are neglected, areas where one thinks one has a route forward that has not been pursued adequately.
Two last questions. The role of AI. I mean, I'm biased, obviously, but what's your take on this? And
it's enormous, isn't it?
Right.
I mean,
how have you used AI in the institutes?
So we don't use it ourselves directly, except insofar as there is been this AI agent that has been trained on me, basically. So you can go in and play with that online.
Yeah.
But of course, in the field in general, you've got things where you've got a particular target, a particular aspect of aging that you're going after, and you might be able to use AI to develop new drugs or new ideas for drugs that way. And that seems to be going very well. In silico medicine is really the poster child of that right now. They went public not long ago.
Good friend of mine, Alex.
Absolutely, good friend of mine too.
I know.
But then also you have to remember all of the stuff that's not specific to aging that covers the whole of biomedicine. So there, the most obvious example would be AlphaFold, which is relevant, of course, to pediatrics just as it is to gerontology. And there are plenty of other examples like that coming along. So yeah, AI will play just as central a role in this field as it does in the rest of life.
And my last question, because it's a podcast for everyone and everybody wants always to hear what have you changed in your life in the last 20 years when you've been working in the institute. They always has the question. I'm sorry, I have to ask it as well. Yeah. And you're going to maybe tell me nothing.
So it's not exactly nothing, but my focus is always on avoiding dying of anything stupid anytime soon, before I die of aging, because I'm not going to be dying of aging anytime soon. And so, I don't accept seminar invitations to dangerous countries.
Yeah.
I get my health checked pretty thoroughly, quite regularly.
That's a complicated one. What's the perfect health check? I'm not sure.
You don't need.
It's a tough one.
Well, you don't even need perfection. You just need to make sure that you've got a wide range of measures of what's going on, of your insulin resistance or your triglycerides or whatever. I get a pretty high-end version of that. But yeah, so long as you have a reasonably comprehensive idea of what your body's doing and where your weak links might be, what things are starting to look risky, then you've got a chance to optimize what to do about it.
Yeah, so regular checkup and avoiding dangerous countries. I think it's a very good start. Thank you so much, Dr. de Grey.
Pleasure, thank you.
Looking forward to hearing your speech.
Thank you.